Welcome everyone to the series of lectures on large language model. And this is our third lecture, which is based on very key concept that is transformer that has actually changed everything around us in the last 4 to 5 years. There is a very weird line written, which is attention, all you need. I think most of you are aware of what it means, but we'll talk about this. So today we are trying to understand what? We are trying to understand transformer, the architecture, the model architecture behind all the popular large language model that you know today, whether it is GPT, whether it is Gemini, the architecture which is behind these model is transformer. So it is essential to understand transformer. Okay. So why we are studying it? We are studying it because all the state of art AI system that you know today is based on this transformer architecture. Okay. Now, when I say attention, all you need, this is the paper, attention, all you need, which was published in 2017. And if I'm not wrong, it is June 2017, mostly published by the veteran in Google. You can see the name here. And I would recommend to read the paper, but definitely you can't read the paper without having a good understanding of the concept like decoders, encoders, RNN, CNN, etc. But what we'll do today, we'll try to read the abstract. What it says that the dominant sequence transduction models are based on complex RNN and CNN network that includes an encoder and a decoder. The best performing model also connects the encoder and decoder through an attention mechanism, and that's why attention all you need. That has changed everything. This attention, this transformer changed everything. We propose a new simple network architecture, the transformer with attention, based solely on attention mechanism, dispensing, dispensing with recurrence and convolution entirely. Experiments on two machine translation tasks show that these models to be superior in quality while being more parallelizable and requiring significantly less time to train. So let's understand this. And this is the famous the transformer model architecture which has actually revolutionized everything. This was that game changing model, the transformer architecture. So the new large language model, the GPT, the Gemini, is based on this paper. So this paper mentioned two things: encoder, decoder. So we have to understand what is an encoder, what is a decoder. Okay. And is it that we have to have encoder and decoder for all good large language model? Should we have encoder and decoder for all large language model? The answer is, let's see. So the model like T5, BART, Marian MT, MBART, Whisper from Google, Meta, Microsoft, Meta, OpenAI, respectively, are a encoder plus decoder model. So pure transformer model, both component of the transformers are there, encoder and decoder. Okay, the transformer has encoder and decoder in these models. But let's look into these models. GPT, oh, we know that. GPT-4, we know that. Cloud, we know that. Llama, Gemini, all the famous large language model is just a decoder only model. So is it that we can have an encoder only model? The answer is yes, we can have encoder only model, but the names are BERT. I don't know what a BERT is. Robert A, Albert, Distelbert, Dbert A, VIT. You might not have heard about these model, but they are very good model. So it is not the competition that encoder is best and decoder is best, or decoder is the game changing model and encoder is not. And you cannot have a model which have encoder and decoder both. It depends. It depends upon what is your use case. It is very critical to understand. If you want your model to only understand, I want to develop my model to only understand, that's it. Then encoder based models are based only for understanding purposes. So encoder based model work best if it is sentiment analysis. So if it is sentiment analysis, people go for BERT model. If you want to generate the text. You want to interact like in chatbots. That's why ChatGPT, that's why Gemini works on decoder only model, because it is meant to have a scalable way to generate or predict the next token in the decoder only model. If you have encoder and decoder, if you want your model to understand and also generate, then have a transformer based model which has encoder and decoder both. So what we have understood so far, we have understood that in transformer there are two components, encoder and decoder. But a model can be developed with encoder and decoder or only with encoder or decoder. It depends upon what is your use case. So it is important to understand encoder and decoder separately. As a first step, most of most of the student do the mistake to understand encoder, decoder simultaneously. No, you can use the encoder and decoder separately. So you should understand encoder and decoder separately first. How they function together, that's another story. But this paper also talks about something very critical, that is attention mechanism. That is attention mechanism. So it is important that you not only understand encoder and decoder, you also understand attention. Now, attention is not a neural network. Attention is not an architecture. Attention is not a system. Encoder is a neural network. Decoder is a neural network. Attention is a math. It's a math which is embedded inside encoder, which is embedded inside decoder. It's a component of encoder and decoder. Let's look at attention, encoder, and decoder at high level. Attention is a math operation. What is attention? Attention is a math operation that it decide what is important and what is not, what is relevant, what is not, in both encoder and decoder. Can we say that we can remove attention out of encoder? No, it won't function the way it should be. It's a component of encoder. It is a component of decoder. Encoder is a neural network. It is a deep neural network. Decoder is a deep neural network. Encoder plus decoder is a system of neural network. But encoder is a neural network that is built to understand. It just understand. Decoder is a neural network which is built to generate output, to predict the output. Okay, this is a very high level understanding of attention, encoder, and decoder. But we'll try to deep dive into attention. We'll try to deep dive into encoder and decoder. Okay, so first of all, let's deep dive into attention. We'll just look into the definition and we'll try to understand what it means. Attention is a mechanism, not a neural network, not a system, that lets a neural network model or any model to decide which part of the input are important and which are not for the current task and focuses on them more than other. Relevance, relative importance, relative importance. To decide relative importance, I'm going very specific, relative importance of every token in the universe. Relative importance of every token related to a given token in the whole universe. What does it mean? First of all, let's try to understand attention at a very high level. Okay, think from the perspective of a human being. If I ask you to read a sentence, Aman loves to read books. Where is your attention? Or the specific question should be where you're giving more attention to. If not right now, let me ask the question. What does read related to? What is read related to in this sentence? Amal loves to read books. Your focus will shift to Aman's and books and might ignore completely to and loves. This is called as relative focus or selective focus. Okay, so we also operate in the same way. Now, if I change the significance and if I ask that what does Aman related to? Now your focus will shift. So Aman loves to read books. So what I'm trying to do, how Aman is related to each token or each word in this sentence, or how loves is related to each token or each word in the sentence. Okay, so Aman loves to read books. How loves is related to Aman? Let's say it is 60% related to Aman. Loves is 100% related to loves. 2 is 0.02% related to loves. Read is 30% related to loves. Books is 10% related to loves. So this is called as selective focus or selective attention. It is not like that if you're reading Aman and if the next word is loves, so loves will give more focus to Aman because it is next to love. Or if it is two, then two will give more focus to love and less focus to Aman because it is next to the next word. No, it is not sequential. It's not sequential. Okay. So this is attention. This was attention. Let's read the definition of attention before moving to encoder. Attention is a mechanism that lets a model to decide which part of the input are important for the current task or the current token and focus them more than others. That is attention. Relative importance. Encoder. Let's read the definition of encoder before understanding encoder. Encoder is a neural network that reads the entire input sequence at once, not sequentially. Not sequentially. It reads the entire input at once, not one word at a time, and converts it into a contextual vector embedding using self attention. So it is using self attention to convert the sentence into a vector, and that vector has a context. Let's understand it. So this is my encoder, which started working on Aman loves to read books. The first task of an encoder is to convert each word or each token into a vector. This H1 represent a vector. This vector could be two-dimensional, could be three-dimensional, could be multi-dimensional vector. We don't know. It could have like xi comma yi, or it could have like xi comma yi comma ji representation on a two-dimensional space or a multi-dimensional space or a 3D space. We don't know. But it converts every token into vector, whether it is Aman, whether it is loves, whether it is two, whether it is read, whether it is book. H1, H2, H3, H4, H5 are what? Vectors. But the important part is these vectors are context aware and dependent on all other tokens. The encoder is able to do this with the help of self-attention mechanism. Let's understand how. We'll see what encoder actually does and what it doesn't. But so let's read the sentence. Aman loves to read the book, and let's try to understand how encoder is converting it into a vector and a contextualized vector. So Aman and book, they are entity. So Aman is sitting here and book is sitting here in the first quadrant because they are entity. Now love is a feeling that is sitting in a quadrant 2, which is the quadrant of feeling. Read is sitting in a quadrant 3, which is a quadrant of action. And to and the are not so relevant information. To and the, they are sitting where they are sitting in a fourth quadrant where we are not giving too much of importance. However, right now we are just converting the whole sentence into a vector, a contextualized vector. This is also called as vector embedding. Now let's expand the sentence. And we'll see that how this whole sentence, this complete sentence, will be converted into a vector and a contextualized vector, which has a context awareness. So Amal loves to read the book and Shamli hates to write. What will happen with Shamli? Shamli is an entity, so we'll go into the first quadrant like Aman and book. But the problem is Shamli is a subject like Aman. So it will sit very close to Aman because it's a subject. It's a subject because it's a subject. So it sits very closely to another subject, which is Aman. Now, hate, which was the feeling quadrant. So, second quadrant is the feeling quadrant. So, hate will sit in the feeling quadrant and very near to loves. very close to it. So the distance between these two vector would be the least. And then write, which is a token, which will sit in the third quadrant with read. And this is the way the whole sentence get converted into vector and the context get embedded into that vector. This is the function of encoder. This is how encoder function. If there is only a model which have encoder, please understand the model has understood the sentence in a vector form and contextualize that vectors in the form of the distances between the vector. So if you want a model to just understand, use encoder. That is sufficient. If you want to encoder, if you want to interact, then you have to go to encoder. Let's understand very clearly what encoder does. The first and the most important, encoder does not do work in a sequential manner. It look at all the words together. So it means it read the whole sentence. Aman loves to read the book in a go. It's not sequential. That is the task of decoder. Okay. Process the entire input sequence at once. Everything happens simultaneously in encoder. Nothing is sequential. Uses self attention to relate every word with every other word. So you cannot separate out encoder with self attention. Then builds contextual understanding of the input through what? Vector embedding. Contextual vector embedding. That is the responsibility of an encoder. What it doesn't do. It does not generate anything. It just understand. That's it. It is not going to interact with you. It won't predict anything for you. It just understand. Does not predict, does not generate, does not chat. That is a responsibility of a decoder to predict, to generate, to chat, to interact. So we'll talk about the decoder. So attention is done, encoder is done. Let's enter into decoder. But if you want to imagine a multi-dimensional space of different sentences and different words, how they get converted into token, then you can see that Aman is here, Shamli is here, Loves is sitting just in front to Loves. Two is there, read and write are sitting next to each other. Book, notes, they're sitting next to each other. This is a way. This is a way to understand that how the vectors are being embedded with the context in a multi-dimensional space. Okay. It could be 2D, it could be 3D. It depends upon the complexity of the problem. The next that we have to understand is decoders. It's decoders. But let's read the definition of decoder. Decoder. A decoder is a neural network. It's a neural network that generates output tokens sequentially using, very important, supercritical, masked self attention and previously generated context. First, decoder is a neural network. For what? To generate, to predict. Whether you say generate or predict, it is up to you. The next token, and it works sequentially. It works sequentially, not the way encoder read the entire sequence at once. Decoder works sequentially using something called as mask self-attention. Why it is using mask self-attention? To learn. And once it is learned, it will generate the context based on previously generated context. We'll understand how. We'll understand how. So let's deep dive into decoders. Now, how decoder function. If you understand this slide, you understood everything. Decoder will have a partial sentence. Aman loves to. And in the sequence. And you're training the decoder to predict the next word. So what you did, you blanked the next word, which was read. You were aware that the word was read, but you blanked it. Why? Because you want to train the decoder. You want to train the decoder. So what decoder will do? Will try to think that what is the most likely next word, and it predicts read. How it correctly predicts read. We'll talk about it. But its responsibility is to just predict the next word. Now, the context that decoder has is Aman loves to read. What next? Is it book? Is it the? Is it blogs? Is it LinkedIn profile? What it is? What Aman loves to read. Can you see that it is always moving left to right? Or you can see if this is my past, I'm trying to predict the future. So if it is always moving left to right, it is never moving right to left or from future to past. It will never happen. If you don't understand anything, please understand this feeling that the future must not influence the past. The same discussion that we do when we discuss about the time theory, the theory of time. We discuss these concepts, right? So future cannot influence the past and must not influence the past. Encoder uses unmasked attention. This was the unmasked attention to understand or to train themselves. So decoder uses masked attention to generate. So what it did, it masked the attention. It masked the word read to predict the read. Okay, but how it predicts, how it learns to predict. So Aman loves to, as it is trying to predict the next word or trying to learn to predict the next word, it is going to be a probability based model. So there would be multiple words that will come: read, write, eat, play, sleep. And there would be probability associated to each one of them. So decoder, to select the next word, first create a probability distribution. This is a probability distribution of different words, but does not select only based on highest probability. This is also important. You might have said that Aman loves to read is the answer because 0.62 is the probability associated to read. No, there is a selection based mechanism. There is a rule for selection. Now, the rule for selection is dependent upon multiple things. You can have a probability based or highest probability based rule that select which has the highest probability. But there is a problem with that model. The problem with that model that every time you write Aman loves to, it will always predict read. So that is a problem with the model. So therefore, GPT have a different sampling based rule. Because if you every time say highest probability, you are making the model deterministic. It is not a general model. Okay. So there are different selection methods. One could be choose the highest probability. The answer would be read. It could be sampling. It could be greedy or low temperature sampling. So there are different sampling method. But yes, the first step in the decoder is to generate the probability distribution. And then there could be multiple selection method, highest probability, sampling, whatever. We'll learn about the selection method. But understand what decoder is doing. It is trying to predict the next token or trying to learn to predict the next token by masking the information. What is the meaning of masking? Deliberately removing the information in the right side. Okay. And it tries to learn that how to predict. Okay. Once it is learned, when you query it, it predicts the next word based on the learning, based on the weighing, based on the sampling methods that it has learned. Okay. So what decoder does? Super important. Generate text one token at a time. It is very different from encoder, which read all at once. Uses masked self-attention to look only at past tokens. So basically, it masks one of the word which is in the right, and based on whatever written in the left, which is the past, try to predict the future. Decides the next word based on the context. Can attend to encoder output. Important. Those who were thinking that why we are not trying to connect encoder with decoder, a decoder can also look into the vector embedding of encoder as an output of an encoder as an input to understand more or try to predict the next word. Okay. Definitely produces probabilities of different words or different tokens. It cannot see the future token. It is always left to right. It always sees the past to predict the future. It cannot see the future. Does not process the full output sequence at once. This is the responsibility. Anything at once is done by encoder. Does not build bidirectional understanding. Bidirectional means if there is a word aman, loves, to, this means that love can see to aman and aman can see to love, which was happening in the pictorial representation of attention in encoding. But here it will always be aman looking to loves and then trying to predict to, so and so forth. Whatever be the sentence. Cool. At a very high level, if you haven't understood anything, please understand encoder is there to understand only. Decoder is there to generate or predict the next token, not the complete right hand side, not the complete future. And attention is for focus. What is important? What is relevant? With that, we'll pause here. See you in lecture 4. Thank you. Have a nice day.